That is the 50 unit is pictorial drawing. Pictorial drawing. Pictorial drawing is nothing but drawing in three-dimensional views. Okay, to have more visualization of a component. Right? We will be using a three-dimensional view in our technical drawing in the right column. Right? So in pictorial drawing, we have already seen the isometric view, isometric projection. So isometric projection is meant for small size components. Normally smaller mechanical components will be shown in isometric view. Right. For larger, I have a perspective projection. So that's what we are going to see today. The other of, okay, again both are three-dimensional view. This is also a three-dimensional view. Right. This is also a three-dimensional view. It's a perspective projection. So this is meant for larger objects. Right. Larger size objects will be shown in perspective projection. Can you have any examples? Larger size building drawing. Okay, technically any architectural drawing, building drawing will be shown, civil engineering drawing will be shown in perspective projection only. You can see in day-to-day newspaper the proposed drawing, proposed building drawing will be shown before the construction itself. Okay, it will be shown in perspective projection only. Right. So we will come to this. Isometric, you know, isometric, it is a single view drawn to, it's a standard single view drawn to three isometric standard axes. Right. So here, perspective projection it is for larger objects, and I can say it is a more realistic 3D representation than isometric view. It is a more realistic 3D representation. Why I am saying it is more realistic? Why I am saying it is more realistic than isometric? Because it is nothing but how the object appears to an observer's sight. Okay, that is this view is nothing but the perspective. If I look at an object, okay, that object how it looks to my eye. Okay, that is the view is nothing. This is the perspective view. If I look at the object, how it is looking to my eye, it will be drawn on a planar sheet. That is nothing but the perspective view of the component. So it will be more realistic than an isometric view. So I can say it is a photographic view. It is a photographic view in the sense you have a camera, if I capture an image of any object, anything, so that is nothing but the photographic, it's typical perspective view. Right. If I take a photograph of this, from this location, how it appears, that is nothing but the perspective view. So it is a realistic view, it's a photographic view. Right. So it is not for mostly technical drawing for larger objects. Right. So take what is perspective view. Suppose it is perspective view. It is the view of an object. It is a view of an object. How it appears to an observer. How it appears to an observer's eye. When it is drawn on a planar sheet. When it is drawn on a planar sheet. Right. So that is the perspective view. So when it is drawn on a planar sheet. Right. So you see in isometric view, isometric three-dimensional view, I will have a single standard view. It is drawn strict on to the standard three isometric axis. I will have a single view for that. So, but in perspective, if I look at this object from here, from my eye, it will appear in a perspective view. If the same object, if I look at from here, some other location, so the view will differ. So I will have infinite perspective view for an object. Same, wherever I fix my camera, it depends upon the position of the camera and the distance of the object, the view of perspective view will differ. Okay, so you don't have a fixed standard perspective view. Right. It depends upon the observer's location and the object location. I can have an infinite perspective view. That is the difference I have. Right. So, perspective projection, it is drawn for mainly architectural, civil engineering drawing. It is used. Terminology. So I am going to just look at the setup. Okay, in perspective projection, similar to your orthographic projection. Okay, in perspective projection, listen all of you. I will have a. Okay, try to visualize in three-dimensional manner, right? So I will have a horizontal plane. Look at this. I will have a horizontal plane. Right? Okay. This is a flat horizontal plane. Okay, it is termed in perspective view. Normally, it is termed in perspective view. It is as ground plane. So normally it is denoted in perspective view is GB. Right? It's ground plane. Listen, this ground plane. So normally the object is kept in this ground plane. So normally the object is kept in this ground plane. You see, my object I am going to keep it on the ground plane. Something like this. The object is kept in this ground plane. Right? The ground plane is nothing but a horizontal plane where the object is kept. Right? Then I will have a plane, vertical plane. So normally it is termed as picture plane. Vertical plane perpendicular to the ground plane. I will have another plane perpendicular to the ground plane. I will introduce another plane. That plane is called picture plane. Picture plane. Why it is called picture plane? The image of the object is captured in this plane. So that's why it is picture plane. So it is a vertical plane and it should be a transparent plane. Right. Then, apart from this, so I will put the object, the observer will be standing from the ground plane, looking at the object like this, right? So when he is looking, the perspective view of the object is perspective view of the object is obtained on the picture plane. Right? So clear? Now, one more thing you should remember. Here, the location of the observer's side, it is going to be termed as station point. Okay, the location of the observer's side, so this is the location I. So this is termed as station point. Normally it is denoted as SP or E. So station point is nothing but what? It is the eye of the observer. The station point is nothing but the eye of the observer or the lens of the camera, right? So station point is the eye of the observer. So you can say it is eye. Right. So otherwise it can be denoted as E also. Right. Is it clear? So the location of the station point will be given into a perspective from, right? The location of the station point will be given into a perspective from. What is that location? It will have some distance above the ground plane and it is some distance in front of the picture plane. Okay, that location will be given into a perspective from. So I am going to introduce another two plane which is passing through the station point, that is eye of the observer. So a plane I am going to introduce that is parallel to the ground plane and perpendicular to the picture plane. I am going to introduce another plane. See here. Right. This plane is named as horizontal plane, not horizontal plane. It is a horizontal plane. Horizon horizontal plane. Normally it is denoted as HP. It's not a horizontal plane, it's HP. Picture plane will be denoted as PP. Picture plane. PP, right? Then one more plane I am going to introduce. That is the thing. Again, it should pass through the station point, that is eye of the observer, and it will be perpendicular to all other three planes. That is picture plane, will be perpendicular, horizontal plane, then ground plane. So how it will be as the plane I have introduced? Plane will be like this. Plane will be like this. Can you visualize? I have another plane which is perpendicular all other three planes. That plane is the center plane. That is denoted as same, right? Center plane which is passing through this eye of the observer, at the same time it is perpendicular to picture plane, horizontal plane and ground plane, right? So remember, I have in my perspective setup, I have four planes. One is horizontal ground plane where I am keeping the object, right? Then perpendicular to that I will have picture plane where I will capture the image of the object, right? Perspective view of the object. Apart from that, I will have two planes at the passing through the eye of the observer. That is, at the eye level, I will have a horizontal plane that is parallel to the ground plane and perpendicular to the picture plane. Then another plane passing through the again the eye of the observer, which is the center plane, which is perpendicular to horizon, ground plane and picture plane. Right? Can you visualize this in a 3D setup? Okay, so in my perspective setup design, I have four planes and an object and a location of and an eye. Okay, station point. So I am looking at this whole setup. I am looking at this whole setup because the observer is here. It is the front direction of the observer. This is the direction the whole setup is looked into. So this is the front direction. I am going to use it. Right. What I am going to draw it. So the perspective setup, this is just for your observation. But we are not going to draw the three-dimensional setup at all, right? So I am going to draw the layout for the perspective view. Okay, the whole setup will be drawn in a layout. The perspective layout I am going to draw it. So normally the perspective layout, you can see the layout of the perspective, it is drawn in three-dimensional view. Layout of perspective. It is drawn in third angle projection. Okay, because it is convenient for and it is easy to get the perspective view in if I draw the layout of this setup in a third angle projection. That's why we are going for a third angle projection. You know third angle projection. So far we are using first angle projection. So the layout of the perspective, it's drawn using third angle projection. It is just for the easiness of constructing the perspective view. So you will be using the third angle projection. So we will be adopting the third angle projection to draw the layout alone, not the perspective view, right? So once the layout drawn using third angle projection, then the perspective view will be obtained easily, right? So you try to tell me the layout for this whole setup. I have 6 components, objects here, 4 planes, object and a station point, right? So this is the front direction I am looking into. So what is the third angle projection? Where I will have the front view, where I will have the top view. As per third angle projection, any object's front view will be shown below the top view, right? The top view will be above the front view, right? You know first angle projection. So in the reverse, in first angle projection, I will have the front view on the top view below the front view, right? But in third angle projection, top view will be on the top, front view will be below that, right? So the whole setup will try to represent the top view, right? So suppose first of all the top view, this is the front direction, the whole setup I have to look it from this one. Okay, that is going to be my top. First of all, you tell me in my top view, which plane will be seen as a horizontal line? Suppose I am looking at this top view, horizontal plane will be seen as a center plane will be seen as a horizontal line, vertical line. So listen carefully, this is the front direction, this is the top direction. Which plane I can see like this? Picture plane. Picture plane will be seen as a horizontal line. So picture plane will be seen as a horizontal line in my top view. So I can draw the layout. The picture plane will be seen as a horizontal line. Picture plane. Listen all of you carefully. So this is important, the layout is important, right? So picture plane will be shown as a horizontal line in my top, right? Apart from that, which plane I can see by looking from the top, the whole setup. The center plane will be seen like this, right? Center plane will be seen as a vertical line. Center plane will be seen as a vertical line in my top view. So the center plane, see, now we can see these two planes only as a line. What about this ground plane and horizontal plane? It is seen as a, it's a parallel plane, so it is infinite plane. Okay, even though it is represented like this, it is an infinite one, I cannot represent it in my top view, right? It is a parallel plane, right? So apart from that, the object I can see, the top view I can see. What I am drawing, it is a top view. So the object's top view, what is the top view of the object? It's nothing but a rectangle. Is a base. The base of the object I can see. Where I have to draw that top view? Here, or here? Right side top. Right. Then I will have my top view. So this is the top view of the rectangular prism. So this is my top view. Is it clear? So this is the object. So you have to draw the top view on the top. To draw the layout of the perspective, you have to draw the top view on the top. Then, object is over. In my top view, can I see the station point E? So E I have here, station point. Top view, I can see the station point. What distance it is? Top view, I can see. It is a point. The point I have here, station point. That point I can see it in my top view as well as in my front view. In top view, where it will fall? In front of the PP, exactly where? Which plane it will fall? Center plane. So you see the center plane, both the yellow planes, center plane and the horizontal plane, it pass through the eye of the observer. So definitely in top view, the station point will fall on my center plane. So somewhere here, some in front of distance I will have. So this is my station point E. What is the notation of the top view for any point? Without dash. So front view notation with dash we will have. So without. Now can you represent the positions of these one in my top view? So what is this position? Object, you know, the size will be given. Where the object is normally is kept here in this one. It is behind picture plane or in front of picture plane? Behind picture plane. So this distance will be given in your perspective problem. What is this distance? What is this one? This is the behind distance. Behind distance. Right, it is behind distance. So how I can define the center plane of the object? The object is right of the what? Center plane. The object is kept to the right of the center plane, or I can say the center plane is to the left of the object. So suppose I have the axis of the object here. You see, the object is kept to the right of the center plane, or I can define the center plane is to the left of the axis of the solid. Right? You have any doubt in this? So this also will be given in your problem, right? Behind distance, either it is behind or in front of, is it touching? So then whether the center plane is to the left or the object is to the right, or center plane can be to the right. Okay. So this whole position also will be given in your problem. What is this position? Either, so I can say the center plane is to the left. Center plane to the left of specific things. Objects, axis. Objects, axis. So it is to the left of the object only, but from the axis it is this much distance left. Or from a corner it is this much distance left. That will be given. So this will be given. What will be this? What is this distance? What is this distance of A? In front of distance. What is this distance? Station point from the picture plane. It is the in front of distance of the station point from the picture plane. So it is in front of distance of station point or E. Station point is equal to E, right? So that is, this is about my top view details, right? So these details will be given in your problem. Try to draw the layout, right? Then we will come to the front view of this setup. Okay, the layout is still, it is not finished, right? So we will come to the front view setup of this perspective, right? So this is the front direction. Which planes I can see it as a horizontal line? I can see a front direction, I can see a ground plane. Ground plane all together, you can draw it as a horizontal line to the bottom of your drawing sheet. Right, ground plane. So far I have finished the top view. Now I am drawing the front view details of the same setup. The front view, in front view I can see the ground plane as a horizontal line. So that is my GP. So ground plane as a horizontal line I can see. Apart from that, what I can see it as a horizontal line? Which plane? Horizontal plane. Horizontal plane I can see it as a horizontal line. So I will have a horizontal plane. I can see it as a horizontal line. So this is my horizontal plane. Right. Then I have to show, what about this picture plane? It is parallel, so I cannot show. What is center plane? Front vertical line, the same center plane, all in front view, top view, both it will be same. So the center plane I can see it, the center plane in my top view also, front view also, both are same, seen as a vertical line. Right. So planes are over. Now come to object's front view I have to draw it. So front view of the object is kept from on the ground plane, from the ground plane. So parallel, how to project the top view, and front view, top view lens. I can draw the front view from the ground plane. The front view of the object will be drawn from the ground plane. So this is my front view. Object front view I have drawn. Right. Then what about station point? Front view. In front view I can see the station point also. Right. Station point, where exactly how to mark? On the center plane. Okay, the plane is on the center plane. Still exactly I can mark it. So that point where it intersects with the horizontal plane. Right. So this intersection location, that is going to be my station point front view, E dash. Right. So what is this height? What is this height? Station point. Station points above distance. Okay. What is the above distance of my station point? What is the in front of distance? In front of distance, the top way I have shown. Above distance of the station point will be given in your problem. So that is above distance of station point. So instead of above distance of station point, I can give in another way I can give it. So what station point exactly is my height. So instead of above distance I can give my height. I can give my height. Okay, height of the observer will be given. It is nothing but above distance of station point. So it is given height of the observer. So then anything else you have read. So this is the layer. So all these 6 objects is shown in the perspective layout. First of all, if your problem is given, you have to try to draw the layout as per the problem. Right. You have to try to draw the layout, the details. Once you have drawn, obtaining the perspective way, it is simple. Right. So problem will be running in 4, 5 lines, 6 lines. Right. don't get afraid. Okay, just you can present it like a layout, then you can get the perspective view easily. Right. So you try to remember this layout, even though if you are not understood this setup. Okay. If you are not able to understand this setup, just remember this layout. Okay. What all the details, where I have to mark it. Right. Is it clear? Do you have any clarification in this? So this layout is known as the third angle projection. So top view you have to draw it on the top, front view you have to draw it below. Right. So this gap, GB and PP gap, picture plane gap, okay, sufficiently you have to give it. So what is the maximum gap I should have, including this and this? Right. So you approximately you give 150 mm. Okay. So try to draw the ground plane to the bottom of your drawing sheet. Right. Picture plane on the top. Right. You maintain the gap in between. So that is the summation of these two. Why? Because this, otherwise if you have a reduced gap, okay, lesser gap from picture plane to ground plane, E has to go above, E will come below. Right. So it's a little bit confusion you will have. That's why to avoid that you have a sufficient gap between picture plane and the ground plane. Right. So you will see a road. If I have a lamp post, okay, lamp post of equal length. I have a road. So I have a road. So in front of a road I am standing. The lamp post aligned on one side of the road. So if you look at the lamp post, what will happen? The lamp post size keep on reduces. Okay. Right. The lamp post, suppose I have the lamp post like this. So the lamp post, vertical lamp post, keep on reducing. Right. When I am looking at the lamp post from the road. So if the distance between the object and the observer is moves on, the size of the perspective also it differs. Okay, varies. So in an easier manner you can understand. So you know perspective is nothing but the normal ordinary projection, not an orthographic projection. The normal ordinary projection is nothing but the perspective projection. So I have observer eye. So I have the object. Right. The picture plane I will have somewhere here. If I have the picture plane like this, I am capturing the image on this. So drawing the perspective in this. Right. So what will be the size of the perspective? It is the ordinary projection. So here I am going to draw the perspective view. So what will be the size of the perspective? Enlarged. Right. Object is this. Okay, object is this. The perspective is obtained on the picture plane. So the size of the perspective will be enlarged one. Here it is enlarged. Why it is enlarged? If the object is kept in between the observer and the picture plane, I can get a bigger size of perspective. Right? I can get a bigger. So the same thing, if I have the object, behind the picture plane, right, behind the picture plane, what will happen to my perspective view? Reduce one. So the similar condition, the previous what we have drawn in the layout. Okay. So that is a reduced perspective I have to obtain. Because the picture plane is in front of the object, so I will have a reduced perspective. A reduced size perspective. Right. When I will have the same size of the perspective? On the plane itself. Suppose I have the object touching the picture plane. The object, if it is touching the picture plane, touches the picture plane, have the picture plane. If the object is touching the picture plane, this is the object, this is the picture plane, the same size, that is true size I will obtain. True size I will obtain in my perspective, right? Remember that. So the size of the perspective depends upon the distance between the observer and the object. At the same time, where I am keeping the object, in between the picture plane or behind the picture plane or touching the picture. If it touches the same size, first one I have visual ray method. Visual ray method is just the ray of vision, okay, where it pierces the picture plane, that point will be marked, okay. Then that in the front view that is marked, that is in the top view that is marked. In the top view, where the ray of vision pierces the picture plane, that point, that is intercept, that is marked, then that will be projected to the ray of vision in the front view. So to obtain the perspective view, okay, that is nothing but the visual ray method. The ray of vision's intercepts obtained in the top view, and that locations will be projected to the corresponding ray of visions in the front view. Right. So then I can obtain the perspective view of the component. Okay. See, mostly we are going to solve the problems in this. Okay. So, but it is not specified in your problems. Okay, whether you have to draw in this method or other one. Right. The next one I have vanishing line method, vanishing point method, vanishing point method. So vanishing point. What is vanishing point? First of all, you should know. So vanishing point. What is vanishing point? So it is a point. So it is a point where the image of the object. Okay, I have the object. Where the image of the object vanishes. Okay, that point is called vanishing point. Right. Where the image of the object vanishes, that point is called the vanishing. Make a note. Vanishing point. It is a point at which the image of the object vanishes. Vanishing point. It is a point at which the image of the object vanishes. And you can see, clearly you can see, right? Suppose in front of a railway track, suppose I am standing in front of a railway track. Okay, two rails are, it's a straight track I have, railway track, two rails are parallel. Okay, but if I look at the rail, okay, it goes like the track will be, seems to be converging at a point. Two rails, okay, even though it is parallel, it seems to our eye, it will be converging to a point. That is nothing but the image of the two rails are getting vanished at that point. That point is nothing but the vanishing point. Normally, this point if you see, where it will fall, if I stand and look at that rail, it will exactly fall in my eye level. So eye level, what plane I have? Horizontal. So normally the vanishing point, this is the point, vanishing point. Vanishing point normally falls on the horizontal plane. Always it falls on the horizontal plane, you make a note. Vanishing point always will be on a horizontal plane. Our horizontal plane is nothing but the eye level of the observer. Always the vanishing point will be on the eye level of the observer. Right. Now, in vanishing point method, I have one point perspective, one point in the sense, one single vanishing point perspective, one point perspective, one point perspective. I will have only one vanishing point. You can see here, I have a top view. Okay, in the horizontal plane, I have a vanishing point, single vanishing point. This is my front view. Because all these surfaces get vanished to a single point. Right, if I draw it, this is going to be my perspective of, you see, all the faces gets vanished to a single point. So this is the perspective view. It will give some appearance, right? So it's a single vanishing point method, right? Is it clear? So similarly, I have two vanishing point, 2 point perspective. I have 2 point perspective. Normally, you can see in single point perspective, we will be going if this face of an object is parallel to my picture plane. Normally we will be going for single point perspective if the face is parallel to the picture plane, similar to this setup. The face is parallel now, so this is my picture plane. The face is parallel. If it is parallel, I can go for a single point perspective. Right. So in 2 point perspective, suppose I have a face like this. Faces now, how it is? The faces of the cube, you see, in top view, the faces of the cube is like this. It is inclined. Okay. So for this also I can go for a single point perspective. But if I want to show the more realistic perspective view, I have to go for 2-point perspective. Right, 2-point perspective in the sense I will have horizontally, I will have perspective vanishing point, so it is in the right side. So it is the right vanishing point I will have. So then I will have left vanishing point, left side. What will happen? This faces, inclined faces, will vanishes to the right vanishing point. So whatever this faces we have, inclined faces, it will vanishes to the left vanishing point. So how I will have the perspective for this? You can see different. So I have here. So these faces will vanish to this. Right. These faces will vanish to this. So I will have my perspective view. Right. Now the perspective view. So it is more realistic than this. If it is an inclined surface, so the same is a 2-point perspective. The same thing I can draw it in single point perspective itself. Right. But show it, represent in a more realistic manner, I have to go for a 2-point perspective. If two faces are inclined. So similarly, I have a 3-point perspective. 3-point perspective. So if I have the same object, if it is a parallel, I can have a single point perspective. If it is inclined like this, I can go for 2-point. If I look at from the top like this, the inclined surface, three surfaces if I am looking at. So this is this face and this face. So I have to introduce another vanishing point, just go down. Okay, apart from these two right and left vanishing point, I will introduce another top vanishing point. Right, that is 3-point perspective. It is still realistic if the surface, 3 faces of the object has to be shown. Right. So that is 3-point perspective. So this is about vanishing point method. Okay. So what is vanishing point? You try to remember. So it is a small problem using visual ray method. Right. Take the problem straight away. A cube of size, cube, you will have only one specification, right? What is that? Size, one cube of size 40 mm. Cube of size 40 mm is kept on the ground plane. It is kept on the ground plane such that your face parallel to the picture plane. Your face is parallel to the picture plane. Face parallel to picture plane. 10 mm behind it and 10 mm behind it. So 10 mm behind it means what? 10 mm behind the picture plane. What is the details I have in my layout? You see here, cube top view and front view both are going to be same. Cube top view and front view both are going to be same. What is the top view of the cube? Square. Front view of the cube? Square. So one face is parallel. The cube I have to draw it. One face is parallel and this distance is given. What is that? 10 mm. And size of the square is given. That is 40. That is 2. Right. So this is the first detail. Then I am going to tell about the station point. The station point is 50 mm in front of the picture plane. 50 station point 50 mm in front of picture plane. What is the distance? In front of distance, I can mark E clearly on center plane. In front of distance is given. Come on. 60 mm, 60 mm above the ground plane. E dash location is given from the ground plane, that is 60 mm above the ground plane is given. 60 mm above ground plane. Right. And lies on the center plane. And lies on the center plane. Which data is missing here now? Still. Lies on the center plane. Lies on the center plane, which is station point always should lie on the center plane, right? It need not be specified in your problem, right? Lies on the center plane, which is 50 mm to the left, which is center plane, 50 mm to the left of the center of the cube, right? So you have to mark the center of the cube. From the center of the cube, the center plane you have to draw it to the left of 50 mm distance. So on the center plane I have to mark this above distance, that is above distance 60 mm, E dash 50 mm, E I have to mark it, right? Then 10 mm I have to draw the front view and top view, right? Try to draw the layout, okay, parallelly with me, right? This is the problem. This way the problem is given. So draw the perspective view of the cube. Draw the perspective view of the cube. The problem is draw the perspective view of the cube. See here. So you draw the picture plane on the top as a horizontal line. This is my picture plane. Right. So immediately you draw the ground plane on the bottom, right? Ground plane. Okay, leaving sufficient gap between picture plane and ground plane. Okay, almost 150 mm you give approximately, right? So including this 50 and 60, 110 to 150 you give, right? Gap. So this is my ground plane. Right. Then immediately you draw the top view and front view of the object given. Okay. It's a cube. So cube front view will be a square. Cube front view will be a square. So everything you draw it into H pencil. In your view, only the perspective view alone should be darkened, right? Draw it into H pencil, don't darken in anything. Right, listen. The top view where it will be, it is the face is parallel and it is 10 mm behind. So from here 10 mm you will be behind. Then you try to show your top view of the cube. Right. So this distance is 10 mm. Right. So neatly you give the notation. One more thing you should careful in perspective view is carefully rotating the notation on the appropriate location. Then top I will have another base notation, right? You see here, this is my A. So in my front view only I can show two bases, right? So this is my front view. I am representing a base and another base on the top. So this is B, Q, R, S. Right. Now these notation carefully mark it to your top view. Right. These notation carefully mark it to your top view. Top view I can see two bases. Okay. Altogether, this is my A, B, and this is going to be C here. This is going to be C, and this is D. Similarly, P, Q, R, S. You should not make mistake in this notating the corner. Here I will have the base A, B, C, D here. P, Q, R, S here. Here it is A, B, C, D, and P, Q, R, S. All two bases will coincide in a same place, right? So this is how I can notate. So if you want to be in this front view with that, you can notate it. Right? Then we have to notate it with that. Listen, one more thing I have to represent. What is that? Station point, which is going to be on the center plane. It is given. Center plane is 50 mm to the left of the center of the cube, right? So which is the center of the cube? Cube center is this. You mark the cube center. So from here, measure 50 mm to the left. Right? From here, you measure 50 mm to the left. I can mark. I can draw the center plane. I can draw the center plane. So my center plane is this. This is my center plane. Right. Distance is 50 from the center. Distance is 50 from the center. Right. So on the center plane, I have to mark the station point E and E dash. So that dimension also given. It is 50 mm in front of. This distance is 50 mm in front of. This is 60 above. So 50 mm in front of, we can mark it. Right, this distance is 60 mm above. So I can mark, this is my E, this is my E dash. Right, so this distance is 50. So this distance is So this is how I can show my layout. Depends upon my problem. So this is the location of my horizontal plane. Right. So if the problem is given, you try to draw the layout like this, right, at an appropriate location, right, in 2H pencil. Both your views should be drawn in 2H pencil. You have any clarification? Just your work is this. Hereafter it is very simple. So neatly you mark the notations. You don't make mistake in notation because you have to trace the notation points. Okay, carefully. If you made the mistake, you will suffer. Okay, you will find difficult. Have any clarification in this? Immediately you represent the, draw the line. Now this is, then you have two steps. Design first of all, since it is a visual ray line, so the eye in both in top view and front view I have the location, right? So as I told, I have to get the intercept of the visual rays with the picture plane in the top view, right? Listen. So the intercept is nothing but, suppose this is my eye, okay? From here I am looking at the object, okay? I will try to draw the perspective of a single edge first of all. See, I have the edge. What is this AB? AB is nothing but the edge of the cube, right? I will try to draw that edge of X perspective, AB X perspective, we will try to draw it. So what I am going to, I am looking at the edge first of all. You see, so this is the ray of vision. I am looking at the edge, right? Where it intersects, listen all of you, where it intersects this ray of vision to my picture plane, that is the location of intercept AP. So the AP's intercept is nothing but this. So remember, intercept is nothing but the ray of vision where it intersects the picture plane. Exactly, that location is my intercept. Now, again the same ray of vision, so this I have to project it to the ray of vision in the front view of the corresponding corners, right? H. So what is the ray of vision here? What I am going to do, I have this station point I here in my front view. So where I have A here, A I have here. Where I have P, P I have here. So I have to look at the edge, A and P. I will draw a ray of vision like this. Right. So these two lines is nothing but the ray of vision in the front view. Right. This is A, this is P. Now this intercept, if I able to project to that ray of vision in the front view, so that is the location of my perspective. That's it. So if I project this, so I have projected neatly. So I have the perspective location of A, I have the perspective location of P. So you have to notate your perspectives in your perspective view in capital letters, similar to isometric view. So this is going to be my perspective view of the single edge alone, single edge AB. Have any clarification in this? So this is how I have to get my perspective. Right. So someone I have to get the intercept from the visual ray line to the picture plane in the top view. Then that intercept location has to be projected to the corresponding visual ray line in the front view. That location I can mark it. That is my perspective location of the corners corresponding. Now this is the perspective view of the edge AB. So similarly I can get for the 4 edges. So the same procedure you proceed it. So you get the intercept of each edges VQ. Right. Then the intercept of CR. Right. That is my intercept of CR. Then the intercept of DS. DS. Right. So similarly I can get the intercept of all the edges. So similarly I can draw the visual rays for all the edges. So 2 I have already. So this I can draw 2 more. Now these intercept location can be projected to the corresponding visual ray line. So DS I can see since the face is parallel, in your perspective also these corners should be parallel. So you should carefully use your drafter. Suppose I have A, B has to be exactly horizontal. So if you are projecting wrongly, if you are using your drafter tilted manner, you won't get exact location. Okay. Since the face is parallel, A and B will be on the same horizontal line. Similarly, P and Q will be on the same horizontal line. Right? You should be in a horizontal location, you should obtain. Otherwise, your projection is, you have tilted little bit, right? So, carefully you get, now I have A here, so B I have here. Then, this is my C. This is my D. B, Q. Right. So by joining this, listen carefully. So the front face you can see fully. Similarly, Listen all of you. Once you have got the perspective points, right, neatly you join the perspective points. Okay, try to show the visible edges in your perspective first of all as a continuous line. Right, here, once it is shown, the hidden corners also you can show it in perspective with a dotted line. hidden edges also you can show it in a dotted line. Right. Only the perspective should be darkened. In H pencil or H pencil you darken it. Right. Remaining things should be into H pencil. Have any clarification in this? This is going to be a perspective view of the cube. You see here, what is the size of the perspective here? So since the object is behind the picture plane, the size of the perspective view of the object is reduced 1. Here it is reduced. A smaller size I have obtained. Right. Yeah. Square pyramid. A square pyramid. Square pyramid of base side 30 mm and height 50 mm. Of base side 30 mm, base 30 mm, height 50 mm is kept on the ground with its base is vertically kept on the ground such that a base edge touching the picture plane. A base edge is touching the picture plane. So behind distance is not given in this one. Base edge is touching, that is 0. Behind distance is 0. A edge is touching. In your top view you have to draw a square with the edges touching the picture plane, not 45 degrees. Right. The edge is touching the picture plane in the sense what? The edge is parallel and it is touching. The edge is touching means all other edges. So it is just something similar to parallel condition. Just the behind distance is missing. It's 0. Right. Then the station point is 50 mm in front of the picture plane. The station point is 50 mm in front of picture plane. 50 mm in front of picture plane. And 50 mm to the right of the axis of the pyramid, and 50 mm to the right of the axis of the pyramid. Where I have to mark the station point. 50 mm to 50 mm in front of the picture plane and 50 mm right of axis means what? Station point has to the center plane altogether. The station point will come to the right side of the axis, right? Object, right? Not like the previous one. So you should have the difference. Then, what is the above distance? It is not given. Draw the perspective view of the pyramid. Draw the perspective view of the pyramid. If the height of the observer is 70 mm, the height of the observer 70 mm. What is this? Above distance of station point. Instead of above distance, I have the height of the observer. Draw the layout. Quickly you draw the layout. Right? Draw the perspective view. You can do it. Same procedure. Just draw the layout quickly. The front top view will be a square with diagonal, with slant edges. What will be the front view of the pyramid? A triangle. Right. You have to get the perspective location of the apex also. Do it. Make it fast. Means a edge is touching the picture plane. It will be like this. The top view will be like this. The behind distance is 0. The edge is touching. So I have drawn the top view. I have drawn the front view. Right. I have drawn the front view for the height 50. Okay. It will be a triangle. Now this station point, as per the column it is given, it is 50 mm in front of the picture plane. I have marked E, and it is 50 mm to the right. So the station point altogether it should come to the right of the axis. Okay. Now, so from the axis it is 50 mm to the right and 50 mm in front of. Then this 70, it is nothing but the station points above distance. Instead of above distance, it is given in this problem, it is the height of the observer, that is 70 mm. I have marked the dash. Okay, this is the layout I have drawn into it. Then you try to get the intercept of all the corners, including the apex. Right? So you see here, so what is the intercept of A and B? Tell me. What is the intercept of corner A and B? If I join it to station point E, a visual ray line, wherever it intersects the picture plane, wherever it intersects the listener of it, what is the intercept of A and B? You tell me what is the intercept of C. So suppose I join C to E, the visual ray line. If I draw a visual ray line to the top view corner C, right, wherever it intersects, intercept means what? Intersection of visual ray line with the picture plane. So this is my intercept of C. Listen all of you, this is my intercept of C. So what is the intercept of A and B? If I join it to E, so the same location is going to be the intercept because it is touching the picture plane. A and B, it is touching the picture plane. I don't need to draw the visual ray line itself, right? It is no use. So B, if I join it, that location where it touches the picture plane, that is going to be the intercept of B. So the location where it touches the picture plane, so this is A. So that is the location of my intercept of A and B. So intercept of A and B is the same location. Okay, even though if I draw a visual ray line, it is of no use, right? So similarly, the intercept of D, get it? The intercept of D. So wherever it intersects, that is my intercept of C. So what is the intercept of O? I have to get it. Right, intercept of O, that is the apex. I have to connect it. So I have to get the intercept of O also. Now, just you have to get only three intercepts. That is D, C and O. A and B are on the same location because it touches the picture plane. Now you draw the visual ray line for your front view corners. Right. Then you take the apex. Right. Now you project these intercept location. Listen here. So what is the perspective location of corner A and B? Anybody? Where I will have corner A and B? So if I project the A dash and B dash location itself, my perspective location of corner A and B. So my perspective location A and B. So what is this distance? 30. So what is this distance? 30. So the same size of 30 mm in my object is appear in my perspective also. Because this edge AB is touching the picture plane. The same size I will obtain in my perspective also. Right? So the size will be same if the object is touching the picture plane. So only this edge is touching. The edge will be same in my perspective also. The length of the edge will be same in my perspective also. So this is the length of the perspective of that edge AB. Now I can get the intercept of other corner C. You see, I have an apex intercept separately. O. So I have an apex visual ray line in my front view. So that you have to project it to the apex visual ray line. So that is going to be my apex location O. So this is going to be my C. This is D. Here, now you have to connect these corners. Okay. First of all, the visible edges you try to show it. So from apex to all the base, I have to show the slant edges. So from O to A, I can join and show a slant edge. Is a base edge. B2C is a base edge. So similarly, O to B, I have to show a slant edge is visible in my perspective. So what about the other base edges and slant edge? Okay, it will be hidden. So this base edge is hidden. Right. This is going to be my perspective of the view of the pyramid. Take product. A square. Listen. A square prism. A square prism. Square prism, base side 25 mm and height 50 mm. Face. What do you mean by face? Square prism have a base and face. Has base and face, right? Vertical face, rectangular vertical. Yep. It is kept vertically like this and the face parallel to the picture plane and face. Remember, see carefully, face is parallel to the picture plane. Parallel to the picture plane and 10 mm in front of it. 10 mm in front of it. You see here, altogether all the whole object it is not in front of. What is in front of? Face which is parallel, that face alone it is 10 mm in front of. Right? So 10 mm in front of it. So face 10 mm in front of picture plane. Parallel. Right? So the station point is 45 mm. The station point is 50 mm in front of the picture plane. The station point is 50 mm in front of the picture plane. In front of picture plane. So this is station point. Station point is 50 mm in front of the picture plane. 75 mm above the ground plane. And this. And 45 mm to the right of the axis. So how I have to draw it? Station point where I have to mark it? To the right side. Similar to the second problem, to the right side. So all the details are given. So only this square prism will be seen in the top view. The rectangle, okay, for the height will be seen in the front view. The rectangle, right? The square, while drawing the square, 10 mm will be in front of the picture plane. You have to draw the square. At 10 mm in front of the picture plane, you have to draw the square. And the face is parallel. Right? Similar condition, I have to draw it. Draw the layout quickly. Draw the layout. Try to get the perspective. Listen here. Since a small portion is coming in front of, okay, try to don't draw the ground plane to the bottom. Why? If you don't have a plane, you see a small portion, if it is in front of, that in front of portion will be in bigger in size in your perspective. So that in front of portion will be bigger in your perspective. So where I will have that bigger portion will come and leave some gap for the enlarged perspective. Here, drawing the layout, okay, it is kept vertically and the face is parallel and the face is 10 mm in front of the picture plane. You have to draw the top view as a square, right? Then front view will be a rectangle for the height 50, right? For the height 50 straight away projected. Then you leave a gap for the ground plane, okay? Don't draw the ground plane to the bottom, similar to the previous problem. Since the perspective view what you are going to obtain for this in front of portion, it will be bigger in size. So I need a space below the ground plane. So that's why I am leaving a gap. But maintaining the gap in between that is more than the above and in front of distance of the station point, because E and E dash do not interfere, right? Then the station point location is given, it is to the right 45 mm and the in front of distance is 50 mm and above distance is 75 mm. So the layout is drawn, then you get the perspective view. Okay, you draw you get the intersect of each corner by joining it to the station point. Similarly, what is the intercept location for CR? CR intercept location is there. Right? What is the intercept of BQ and AB? Suppose I join BQ. Listen up here. Listen. This is important. Suppose I join this BQ to the visual ray line. Whether is it intersect the picture plane, the visual ray line, it is not intersecting. To get the intercept, what I have to do it? I can extend on the same manner to make it to intersect with the picture plane. So the same visual ray line can be extended in the reverse direction. So where it intersects in the reverse direction, exactly on the picture plane, that is going to be the intercept of BQ. Right. Similarly, this corner edge, I don't have an intercept directly. I have to extend it in this reverse. That is the difference you have. Carefully extend. Visual drop properly. So, in a normal visual ray line, I am not able to get the intercept. What I am doing on the same manner, I am extending it to get the intercept on the picture plane. Where it intersects here, so that is the location of intercept AB. Right, I have got the intercepts here. Right, now you draw the visual ray line for your front view. Now, listen carefully. I am going to get the intercept of, I am going to get the perspective location of CR. HCR, I have the intersect here CR. So just I am projecting that. Wherever it intersects C and R, C I have here, R I have here. So that is the perspective location of C and R. So this is my C, this is my R. Listen. So I have a perspective location of H, perspective view of HCR. Similarly, HSD. So HSD, intercept I have by projecting that. At the same location, horizontally I have to get it. Right. So this is going to be my A. This is going to be my D. This is going to be my S. Now, what about AP? You listen. AP. So listen all of it. Listen. The AP intercept is to the left. Okay. So by projecting this AP to the corresponding visual ray line, can it meet the corresponding visual ray line? Whether it is meeting the corresponding visual ray line. So I have AP. Where I have A I have the visual ray line of A ends here. The visual ray line of B ends here itself. So, but I need the intersection. What I have to do it? So the visual ray line of A ends up to here. What I have to do to get the perspective location of A? I have projected AP intercept. What I have to do it? Just extend the visual ray line of your front view. Right? In the same manner you extend there. Where it meets the intercept projector. Right? Corresponding intercept projector where it meets. That location is going to be my perspective location of A. Right? Similarly, P. On the same manner I can extend it where it intersects AB projector, that is going to be my P. Right? So this is the edge, enlarged edge in my perspective AB. So similarly, what is the intercept of BQ I have the intercept here. So by projecting that BQ, I am drawing a projectile from intercept BQ. Right. You see here, again, this intercept projectile, it is not meeting, it is BQ. BQ visual ray line ends up to here, B. Q is ends up to here. What I have to do on the same manner, I have to extend B. So I have to get it on the same location. Right. Q I have to extend it in the same manner. So that is going to be my B. This is my Q. Now this face APBQ, it will be an enlarged face in my perspective. Right. Join this APBQ in sequence. Right. Look at this perspective. Right. The portion which is in front of the picture plane, that portion is enlarged in my perspective view. Right. Look at these three problems. The first one is behind. I have the reduced perspective. The second one edge is exactly touching the picture plane. I have the same size in my perspective AB. Here, it is a small portion is in front of, that portion is enlarged in my perspective, so that you leave a gap for that ground plane in this kind of problems. If you have some portion is in front of the picture plane. Have any clarification? In front of the picture plane, 40 mm in front of picture plane. Come on, 50 mm above the ground plane, 50. 50 mm above the ground plane, 50. 50 mm above the ground plane. Lies on the center plane, which is lies on the center plane, which is 40 mm to the, which is 40 mm to the left of the axis, lies on the center plane, 40 mm to left of the axis. Right. Draw the perspective view of the prism. Draw the perspective view of the prism. Similar to the first problem, right? The cutting plane is to the left, similar to the very first problem. Cutting plane is to the side, not cutting plane. Center plane is to the left, right? The station point in front of above distance is given directly. What is the difference here? Is this solid's orientation. So far the solid was kept vertically like this. Now the solid is like this. So this is going to be the nearest base. It is lying on its face. The nearest base is 10 mm in front, behind the picture plane, and it is parallel to the picture plane. That is the difference. So what is the difference in your layout? The top view will be what? Here top view will be a rectangle. Right? Top view will be a rectangle. In top view you have to measure the height. The front view will be a square. Front view will be a square in your layout. Differences. Top view will be a rectangle. Problem, the solid orientation, the solid is lying like this. Right? Solid is lying with a face. And the axis is perpendicular. Your face is parallel to the picture plane and 10 mm behind. So my top view, I have to draw the top view on the top. The top view will be a rectangle. A rectangle, yeah, base is 10 mm behind the picture plane. So what will be the front view? Front view, by projecting the top view, I will have a front view is nothing but my base. It is a square. I have drawn it. That is the difference. The remaining thing, the center plane, that is the station point, is 40 mm to the left from the axis of the solid. and the station point is 40 mm in front of the picture plane. At the same time, it is 50 mm above the ground plane. Right. So I have marked the station point front view and top view. When you try, this is the layout. Then you try to get the intercept of all the corners and try to get the perspective view. Straight. By joining the corners to the station point, top view, I can get the intercept as usual. These are all my intercepts. Now we get it. QR is next to BS, then AD. QR, AD, then BC. Right. Then BC. Intercept. Now you draw the visual rays from the front view. Get the perspective locations. Listen, see here, the perspective view of the prism which is lying like this. I will be updating like this. See, the base ABCD and PQRS, it is parallel to the picture plane. So the base point should be horizontal. Okay, we should obtain the perspective location horizontal to the ground plane. Okay, all the corners should be horizontal. The bases are parallel to the picture plane. So the perspective will be like this. Right. So visualize the dotted hidden edges, we show it in dotted lines. You see, the whole solid prism is behind the picture plane so that the perspective view is reduced. Okay, totally it is getting reduced. Right. Take the problem. A cube, again we will go back, cube, a cube of size, a cube of size 40 mm, 40 mm is kept on the ground plane, is kept on the ground plane such that it faces equally, in vertical faces equally inclined, vertical faces equally inclined to PP, picture plane. So far we have seen the solids face parallel to picture plane. Very well I can go for a single point perspective, that is a vanishing visual ray method. Okay. So now the face, vertical face is equally inclined to the picture plane. So even though here also I can go for single point perspective, okay, same previous old procedure I can follow it, okay, I can get it. But the perspective is, if I go for 2-point perspective, it will be more realistic. That's why if vertical faces are inclined to picture plane, I can adopt vanishing point method, that is 2-point perspective, right? So it is not wrong if you are doing it in a single point perspective, right? You can do it. The type of method is not mentioned. Okay, you are asked to draw the perspective view. So you can adopt any one method. So now, vertical face is equally inclined to picture plane. Full stop. The station point 40 mm in front of the picture plane. 40 mm in front of the picture plane. Station point 40 mm in front of picture plane. And 15 mm 15 or and 10 mm to the right of the nearest edge, nearest vertical edge. 10 mm to the right of the nearest vertical edge, nearest edge. Right. So what is that you will see? Full stop. Draw the perspective view of the prism. If the height of the observer is 60 mm, 60, height of the observer, right. We draw the layout quickly to this orientation. Okay. Only the top view, the square will be equally inclined to the picture plane. And what is that? The nearest vertical face is equally inclined to the picture plane. One more thing is missing. You add it here. Here you add it. Vertical face is equally inclined to the picture plane and the nearest vertical edge is 10 mm behind it. The nearest vertical edge is 10 mm. Nearest edge 10 mm behind B. Right? Because whether this cube is touching the picture plane or behind the picture plane or in front of the picture plane is not given. So what is given? Now it is behind the picture plane. How much is behind? 10 mm. Which is behind? The nearest edge. The nearest edge is 10 mm behind. Such that edge you have to mark it 10 mm behind. Then from that you have to draw the square equally inclined to the picture plane. That is 45 degree inclined to the picture plane. That is the top view of the cube. So you draw the top view of the cube, front view of the cube. No need to draw the front view as was this vanishing point. You draw the top view of the cube, draw the picture plane, ground plane, horizontal plane, and mark the station point. Make it fast. You don't draw the front view here. BQ is the nearest edge or nearest corner, right? Nearest edge. From that, the station point is then to the right of the nearest edge. Right of the nearest edge. So and it is 40 mm in front of. If you are going for vanishing point method or 2-point perspective, what is the thing is, you see here, the top view I have drawn, the faces are equally inclined and the edge nearest vertical. BQ is going to be my nearest vertical. Station point is here, observer is here. For him, the nearest vertical edge is my BQ. That BQ nearest vertical edge is 10 mm behind the picture plane. Right. And the station point is given. It is 10 mm to the right of the nearest vertical edge. So the station point, it is 10 mm to the right of the nearest vertical edge. So this distance is given. It is 10 mm to the right. So this is 10 mm to the right of the nearest vertical edge, the station point. And the same station point E, it is 40 mm in front of the picture plane that is given. Now, you don't need to draw the front view I told. Right? If you are going to the previous method, visual ray method, what you have to draw? You have to draw the front view. What will be the front view for the visual ray method? Tell me. What will be the front view for the visual ray method? It will be a front view will be like this. I can see the front view of vertical edge like this. Right? For visual ray method, the front view will be like this. For this orientation, you have any clarification? So just I have to mark the corners. Then as usual, the previous procedure, the station point, top view will be, front view will be there. You have to connect everything to the front view. As usual, previous method, I can go for the perspective view. Now it is 2-point perspective. I am trying to show the perspective view. Listen, for this I no need to draw the front view. Right? What I have to do, you have to draw the station points, front view location. What is that? It is given height of the observer 60 mm. So height of the observer 60 mm you measure. Right? 60 mm measure. 60 mm. Now on this 60 mm, what I am going to draw? See here, on the 60 mm, the height of the observer previous from what we had. Which plane we had? Horizontal plane. So in a 2-dimensional itself, the horizontal plane, I can show it as HL, that is horizontal line. So that is horizontal plane. Altogether it is the horizontal line. Right. So what is this height of this line? What is this height of this line? It is 60. That is height of the observer is nothing but, or the above distance of the station point is nothing but the horizontal line. I have to draw it. So that is 60 mm. Right. So this you have to do it. Once this is over, so I have to try to get a, listen all of you, not like the previous one, I have to try to get a vanishing point. So this is 2-point perspective, I have to get 2 vanishing points, right side vanishing point and left side vanishing point. How to obtain the vanishing point, listen all of you, how to obtain the vanishing point from the station point. So always vanishing point falls on which plane? Horizontal plane. So my vanishing point, I have to get it on horizontal plane. That is for sure. Now, to get that vanishing point, see here, from the station point, top view, you draw a line parallel to one face, which is inclined to the picture plane. So which face? That is BQCR face. Parallel to that, I am drawing a parallel line. I am drawing a parallel line. So it will meet my picture plane. Where it meets the picture plane? It's a parallel. So it is a parallel line I am drawing. Right. It is a parallel line I am drawing. So it meets the picture plane. So which side I am drawing the parallel line? Right side, face. So from this location, you drop that, project that to where I have to get the vanishing point on the horizontal plane. Horizontal plane, you project that location to the horizontal plane. So this location is my vanishing point location. What vanishing point is this? Right side vanishing point. So this is RVP, right vanishing point. So obtaining a vanishing point, first of all you have to obtain the vanishing point by drawing a parallel line to one face, okay, which is inclined. From the station point, drawing a parallel line and to get an intersection of two picture plane, then you drop that, project that to the horizontal plane. Since my vanishing point will always fall on horizontal plane, horizontal line. This is my right side, so right vanishing point. Similarly, I can get a left vanishing point parallel to the face BQAP. Right. So from station point, I am drawing a parallel line to face BQAP. This is a parallel line I am drawing. So where it meets, so this is parallel to the left face. Right. Parallel to the left face, that is BQAP. I am drawing a parallel line. So use your drafter fixed to this face, draw a parallel line. Use your drafter fixed to this face and draw a parallel line. Right. So then by dropping this to the horizontal line, drawing project line to the horizontal line. So this is going to be another vanishing point. What is this vanishing point? It is left side, so left vanishing point. So I have got 2 vanishing point locations, that is right side and left side vanishing point. Is it clear? So obtaining a vanishing point, drawing parallel lines from the station point, drawing parallel lines from the station point to one parallel face, one inclined face. So I will obtain it on picture plane by dropping that to the horizontal line. I will obtain the right vanishing point. Similarly, left vanishing point I have got. Now to get the perspective. So you don't have the front view. What I have to do it? You know one thing. So if my edge is touching the picture plane, listen all of you. If my edge is touching the picture plane, in my perspective, what I will obtain, the same length I will obtain in my perspective. Do you agree with that, right? If my edge is touching the picture plane, the same length will be obtained in my perspective. That is the concept I am going to use it. So the true height of the cube, I am going to draw it from the picture ground plane. So from this location, I don't find true height for all the vertical edges. Because why? All the vertical edges are behind the picture plane. So what I am going to do, to draw the true height of the cube, I am either I will extend this BQ corner this way, parallel to the left vanishing line or parallel to this face. So either I can extend like this or extend like this. So it's up to you. I am trying to extend, I am going to extend in this manner. So now I am extending parallel to the right vanishing point. Is it clear? I am extending. Now this B2, I am getting an arbitrary location. It meets here, that is my location, say B2, Q2 you have. Right. Now this B2, Q2, if I project it to the ground plane, that B2, Q2 edge will give me the true height in my perspective, isn't it? Since it is touching, this BQ I am extending, assuming it, and I am extending to get the true height in my perspective. So since none of the edges touching, so one vertical edge I am extending either parallel to right vanishing or left vanishing. Now parallel to the right vanishing I have extended, I have marked B2 to arbitrary location. So location. Then I am projecting that to the ground plane. Projecting that to the ground plane. Now conveniently the B2 Q2 perspective I can draw it to which height? 40 mm. That is a true height. Right. Cube's height is 40 mm. Okay, side is 40 mm. So B2 Q2 perspective I can obtain for 40 mm exactly. So B2 Q2. So this is going to be my B2. This is going to be my Q2. So this is not my actual edge of the cube. So this is just the 40 mm true height I am obtaining. So this is 40 mm true height. So this is the difference I have. So once you have to obtain a 40 mm true, suppose the same corner is touching, I don't need to extend at all. Just like you project that corner, if it is touching BQ, just like you project, I can mark that edge BQ. Directly I can get the perspective of BQ for 40 mm because that is touching. The true height I can get it. Now since it is not touching, I am extending in any one direction and getting B2 Q2 perspective. But it is not a perspective edge of the cube, actual cube, right? So now to get the perspective location of BQ edge and CR edge. So in which direction I have extended? To right vanishing point I have extended. Right. So this B2 Q2, I am going to join it to the right vanishing point with two vanishing lines. So this is a vanishing line corresponding to Q2. This is a vanishing line corresponding to B2. You clear with this? So I have drawn B2 Q2 and drawing two vanishing lines for this face to get the perspective of this face, because this face is going to vanish in the right vanishing point. So B2 Q2 marked down. So within this vanishing line, I have to get the perspective view of this face BQCR. Right. So BQCR perspective location, how I can mark it? You know. How I can mark the perspective? I have to vanishing line. Within this I have to get it. How I can get the perspective location? Similar to previous procedure. What I have to do is, I have to get the intercept of these two edges and I have to project it to the visual ray line. Sorry, vanishing line here. Right. So you get the intercept of BQCR. How the intercept is obtained BQCR? You should be very clear with this. Suppose I am extending like this true line, you have to join it to the right vanishing point. Suppose the same thing I am extending like this, I will have a true height here. That where I have to join it? Left vanishing point. Right, that is the thing you should remember. Now I have drawn like this. Now to get the perspective location of this BQ and CR, get the intercept as usual, similar to visual ray line. Intercept is obtained by joining this with this station point. Intercept of this is obtained by joining this with this station point. So these are all my intercepts of BQ and CR. This is BQ intercept, this is CR intercept. So just project this to the vanishing line, corresponding vanishing line. So I have got the perspective view of this phase BQCR. So this is going to be my B, this is going to be my C, this is R, this is Q. Okay. So I have got a perspective view of this phase which is vanishing to the right side. So this is the perspective view of this phase. Do you have any clarification? Now how I can finish the perspective view? Anybody? This phase is vanishing to the right side. This phase is vanishing to the left vanishing point. So it is 2 point perspective. This phase is going to vanish to the left vanishing point. I have a left vanishing point. Now what I can do it? Anybody? So this phase. Now what I can do it? So this edge is going to vanish to the right side. Also it is going to vanish to the left side. This edge BQ. So this BQ. I don't need to join this Q to B2. Right. Once I have got this phase, that this BQ I can join it B and Q of the perspective. I join it to the left vanishing point. So by joining this to the left vanishing point, so this is the vanishing line for the phase BQAP. This is a vanishing line for the phase BQAP. Right. So I can get the perspective intercept of AP and I can project it. I can get the AP perspective here. So perspective or intercept of AP will be obtained by joining to this station point. So this is going to be my intercept of AP. By projecting that, I will get the perspective location of edge AP. This is going to be my A, and this is my P. Right, this is the edge AP, and this is the phase vanishing to the left side. ABQP. Right. So 2 phases I have got, which is vanishing right side and left side. What about the other corner DS? How I can obtain it? So this line, this phase is going to vanish to the right side. This phase is going to left side. What I can do it? Easily. This corner P, I can join it to right vanishing point. This corner R, I can join it to the left vanishing point. Wherever it intersects, that is going to be my PQRS. So this P, I can join it to the right vanishing point. So this R, I can join it to the left vanishing point. Right. So the intersection location is going to be my yes. So I can get the top phase. So PQRS. Similarly, I have another again D. D I can get it. So by joining A to right vanishing point, C to left vanishing point. So I will have my A. So that is going to be my ABCD. So here, this is more realistic since I have two vanishing points. So one phase is vanishing to the right side, another phase is vanishing to the left side. So if I can go for a two-point perspective, only the phases are inclined to the picture plane. Right? It is up to you whether you can go for two-point perspective like this, vanishing point method, or the same problem, you can draw the front view. Right? You can draw the front view. You will have three edges in your front view. This A, B, C, R and BQ edge in your front view. Right, similar to this, you can draw the front view. And the top view will be like this, we have drawn already. Right. Previous visual ray line, you can mark station points E, E dash. And you can project, get the intercept, you can get the corresponding location of the perspective. Similar to the previous problem also, you can solve it. So this is two-point perspective, will give you a more realistic perspective view, since the faces are inclined. Right? Have any clarification? We go through this video step by step. For this, you no need to draw the front view. So you have to obtain the true height. This. So if the edge is touching, no need to extend directly that edge. Perspective will give you the true height. That you can join into right vanishing or left vanishing. Since it is not touching, I have extended to obtain the true height B2 Q2. Since I have extended to the left side, to parallel to the right vanishing point, right vanishing line. Then that I have joined to the right vanishing point to obtain the perspective of this phase BQ and CR. So intercept as usual, previous method I have obtained, I have got the perspective phase of this one. Then this phase BQ, you should not join B2 Q2 again to left vanishing. The phase perspective edge of BQ, that should be joined to the left vanishing point to obtain the perspective of AB. Then the corner SD, by joining BP to right vanishing point or to left vanishing point, the intersection will give me S. Similarly, A to right, C to left, the intersection will give me T. So this is the two-point perspective vanishing point method. Right? The vanishing point carefully you have to obtain from station point parallel to one phase to the right side. I have to project draw a parallel line to picture plane. So draw a parallel line to this phase, it will make picture plane. By dropping that to the horizontal line, that is my right vanishing point. Similarly, left vanishing point parallel to this phase and dropping to the horizontal line, I will get left vanishing point. Right, is it clear? Have any clarification? This is, up to this, we have seen square, pyramid, square, prisms, cube. So problems you may have, suppose instead of in this previous method, square pyramid, if it is a hexagonal prism, you have to draw the front view as, top view as a hexagon. Front view will be a edges for hexagon. Okay. Vertical edges you may have 4 edges. Okay. That you have to join it to the station point as usual the previous method. So instead of square, you may have a hexagon, pentagon also. Pentagonal prism or hexagonal pyramid. So mostly we will be asking in this. Okay. Is it clear? You have any clarification in there? So if you are confusing this, you stick on to the single vanishing point method. Right? So go for the perfect front view also. Right? Exact front view, then get the perspective projection. Great. We will have a small. So your end semester you have machines, right? So in all your 5 units, right? So what is the pattern? You just make a note, right? What is the pattern? You just make a note. So as usual in all the subject you have mostly the same pattern, isn't it? So the first part A is 2 marks. Part A is 2 marks. So you will have 10 2-mark questions. Listen, you will have 10 2-mark questions. So each 2 in each unit. So 2 in each unit. You have 5 units. Correct. Each unit you will have 2 questions, okay, 2 more questions. Right, so far what we have seen, you have come across in 3 tests, go through that, okay, apart from that, okay, the introduction part you will find your 2 more questions, right. Definitions, right, some inside questions, okay, whether it is true or false or statement or the fill in the blanks, like that, right. Then part B, which is the first unit. Part B is 16 mark question. So 5 units, 5 questions, 16 marks. Okay, you will have 5 questions to ask. 5 16 mark questions. Right, you will have 5 16 mark questions. Okay. So in each unit you will have 1 question. So I have 5, you have 5 units. So unit 1, what is unit 1? Unit 1, the first part is, unit 1, the first part is the subdivision A. So this is my 11th question. 11th A will be in your plane curves. Plane curves. Plane curves in the sense, what you have? Conic sections, cycloids and involutes. Right. So in plane curves you have conics, cycloids, involutes. So this is the first half of the first unit. First half of the first unit. For this, the R question will be, the second half of the first unit will be the orthographic projection. That is a freehand sketching. That is either for this we have freehand sketching. So what you have attended in your third test, right? That is your very first question. If you are thorough with this, you can go. So it's up to you. You can omit this question, right? The second, 12th question. So these are all 16 mark questions. The 12th question is part A. So 12th question subdivision A, this is subdivision B. Subdivision A will be, what is the second unit? Straight lines and, so points, straight lines and projection of planes. So you will have straight line problem. So there is big problem including traces. Okay. So you will have straight lines problem. There is one subdivision. Another one for the R portion will be planes. Projection of planes. Plane surfaces. Right. So either one you have to be thorough with that. The third question, that is on third unit. What is the third unit? Projection of solid. It is meant for projection of solids. Right. So your subdivision A will be projection of solid. Similarly, B also will be projection of solid. Right. So projection of solids A, B. So solids, if you are thorough, you will get 116 mark completely. And then 14th question. It is on the 4th unit. Which is your 4th unit? Section of solids and development. One part is section of solids. So subdivision A will be section of solids. Subdivision B, that is R for that, will be development of surfaces. Right. Then 15th question. Okay. Last question is the 5th unit. What we have seen. So the subdivision 1/2 is isometric, drawing isometric views. Another half will be perspective view. Right. So A is isometric projection. Isometric view. So for that, the R either question B will be what we have seen today. That is perspective projection. Perspective view. So you have 5 16 mark questions to answer, then 2 mark questions. Right. The same pattern. Okay, we are at the end of the session. Right. It is almost all the theory portions, okay, what you are going to face in your examination, it's over. This is an introduction of a computer part, computer graphics part, okay. So what we have seen throughout this semester so far, it's only the manual drafting, okay. You have your draft pictures, okay, you have your pencils, erasers, okay, manually you have drawn, okay. Some decades back, all technical drawings drawn by manually only. Only if you know the manual procedure, then only we will go further in computers. Okay, that's why we have kept the manual drawing, okay, as a mandatory in the first semester, right? So once these standards and technical details, okay, it is prevailing, okay, as if we are in a computer environment, okay, the manual technical drawing standards, okay, the procedures, okay, it is prevailing, okay, how you have to read the drawing, okay, everything is prevailing, right? We will see. So apart from manual drawing using drafting instruments, okay, nowadays we are not drawing manually, okay, we don't no more we are using drafters, anything, okay, everything we are using in computers. Okay, what you are doing using drafter, the same thing using commands, okay, we will be able to draw lines, arcs, okay, any geometry we will be able to construct, dimensions, everything we are able to construct using drafting packages. Okay, the very first step in your computers from manual drafting is the computer drafting. Okay, the computer drafting package already you have come across, okay, you may know this now. So many drafting packages are available, okay, that is commercial drafting packages. So one is majorly we are using is AutoCAD, okay, you know that AutoCAD is a pure drafting package. So whatever you are doing manually, the same thing I can do it in AutoCAD, okay, the same three-dimensional views also I can able to draw it, okay. So we'll have the introduction of the drafting package, okay. So say the package is AutoCAD, but we are going to see AutoCAD. Once you have opened, the environment will be like this, okay. You can see in the left side you have so many icons. Directly you have icons, line, arcs, okay, fillets, okay. Whatever geometry you want to draw it is available there in icons. The other thing, before that you have command prompt here, okay. In the bottom of this one I have a command prompt, okay. So then I have a Q line there before that. So whatever you are doing, the Q line will instruct you what you have to do, okay. That Q line will instruct. The command prompt, I can type the command. Suppose I want to draw a line, I can type line. So in some commands I can type one or two letters. First letter itself it's enough. If I type L, it will take as line. Okay, similarly you will be extensively using in your further semesters this. Okay, this is just an introduction. Suppose before that, if you want to set the the area of which you are going to draw it. So it's in a grid. If you want to use something like a graph sheet, I can use a grid. So still accurately I can go for the locations. Okay, there will be a grid. So normally nowadays we are not using this. So before that, suppose I want to set limits. You see the command prompt, I am typing limits. Okay, LIMITS, limits. It is asking for specify lower left corner. Okay, so that is 0, 0. So in the graph sheet, lower left corner and right corner I am going to specify. It's 0, 0. I am specifying this. Already it is 0, 0. So 0, 0. Then specify upper right corner it is asking. So suppose I want 100, 100. So this is the limit. So whatever you want, the area you are going to work, you can set it. Okay, that's something like a sheet which you want to set it. So once I have set the limit, then I'm going to, if you want to show it something like a graph sheet, okay, grid points. If you want to show it, I can type grid. See, grid, it is asking aspect ratio, that is a grid spacing. So graph spacing, suppose 1 mm, 1 mm if you want. I have given the area 100, 100. Okay, x 100, y 100. So I'm giving 1 as a spacing. So I can see, can you able to see the grid? Okay, it's very light. Okay, the grids are locations are there. Okay, it's suppose I want to see all the grids in my window, so I can zoom it. I have a zoom command. Is it I am typing it zoom. Otherwise, whole word you can type it. Is it OOM? So zoom, it's okay. Zoom, you have all center dynamics. So many options inside zoom you have. Suppose a particular area you want to zoom it, I can put a box. I can zoom it and see. Okay, this will be same. Okay, extensively. So zoom all I am typing A, first one A. So I have all the grid area, that is from 0 to 0 to 100 to 100, the grid area I have. So inside if you want whatever drawing you want to draw it, you can draw it. Okay, using commands. Either using commands or nowadays we have icons. Okay, suppose I want to draw a line. You see I have a line here, line icon. Okay, so line I am clicking. Okay. Just from where you want to draw. Suppose I want to draw a reference line first of all in your drawing. So in the middle I am drawing a reference line. So it is wherever, this is a start point, wherever you want to end I can end it. You see it is whatever angle I can draw it. Suppose I want only horizontal, vertical, you have a command. Okay, suppose I want a purely horizontal, purely vertical means, so that is F8. Okay, it's an ortho. So I can draw an orthogonal lines, only horizontal, vertical lines. You see, this is a horizontal. So just by ending that, I have drawn a reference line. Suppose when you are drawing, it's over. A reference line I have drawn it. Suppose I want to construct a pentagon, hexagon or anything. Okay, square, circle. Okay, you have everything in your commands. Right. Suppose I want to draw a pentagon or hexagon. See, it's a polygon. How many sides you want in your polygon, it is asking. So I can give it. So more specific you can go inside. Okay, just on an outline I am telling. So suppose I want 6 sides. Okay, 6 sides. Okay, specify the center of the polygon, 6 sides. So I can pick the center, enter the option inscribe or outscribe a circle you want. Okay, I'm typing already it is inscribe. I am typing inscribe. So I am drawing a hexagon, constructing a hexagon like this one. So this specify radius of the circle it is asking. Suppose I want the side is 30 mm, radius will be 30. Right, it is 30 mm. So radius I am getting 30 circle. Right. So it is too big. It is wrong. If you want to erase it, you can erase it. Same, your eraser like thing. Here you can erase it or delete it. Erase you can go in. E is nothing but erase. You see here. Select object is asking. I am selecting this object. So still I am smaller. I am going to draw it again. Second, that is what is 6 sides. Enter. Right. Specify the center of the polygon. Center. Enter the option inscribe I. Okay. Specify the radius. I am giving 15. Right. I am giving 15 like this. Enter. Right. So this how what dimension you want you can draw whatever geometry you want. Okay, directly by command you know it. Then suppose I want to draw the projection of this. How you will construct? You will draw the projector lines. Extend the projector lines. So again I can go for which command? Line command. So just line command I can draw it. So from here I can go for projector line. So what height you want? You can draw it. Okay. Then horizontal line. Suppose I want to draw it. So then again line I am using from here. Extending. Then I want a line from here. That is again another line. Projector line. Okay, I will have an edge from here. Right. So it is not correct. I want to trim it some of the portions. Okay, it's exactly it is not the front view of that hexagonal prism. Right. So which portion I want to trim it? These portions I want to trim it. I can trim it. So trim command I have exactly to which one you want to erase it. So erase it, then the whole entity I can erase it. Erase command. So exactly some portion. So I want to erase it means you have to go for a trim command. Okay, that's you have a trim command. I can type it trim. Specify the trim. Right. Select object it is asking. That is a cutting edge. Which edge you want to have it as a reference to trim it. Okay, that is it is asking. So for to remove these 3 extension portion, I have to use this line as a cutting reference. Right. Cutting edge. So similarly, to remove these 4 projector lines. Which one I have to use at a cutting reference? The reference line. Okay, I have used. So to remove this extension portion, a small horizontally, I have an extended line. So I am using this as a trimming edge. So 3 trimming edges I have used. Okay, cutting edges. I am giving enter. It is asking now select the trim portion. Which portion you want to trim it? Okay, that portion I can trim it. So you see here, this. Okay, this portion I have to trim it. This portion, this. Right. Now, yes, so the portions whichever I want to trim it, I have trimmed it. Erase. Okay. So I want to draw a horizontal base, top base there. So again I can go for a line command. So I can close this. So this way I can draw it using my computers. Okay, using my commands. Okay, commands are straight away the icons, whatever. This is just a drafting package. I can draw 2-dimensional drawings in this. Okay, how you are drawing in manually. Okay, the same thing I can draw. Suppose I want to dimension it directly. How you see this icon? It's a linear dimension. So just I am dimensioning from here to here. So it is some size. The value of the dimension. Okay, the extension portion, wherever you want to keep your dimension. Okay, you can. Okay, so dimension height, if you want to increase, you can increase it. Oh, the D. Similarly, the arrow head, if you want to increase it. Okay, these are all as a standard. It will come. Right. So that you can do it. Similarly, if you want to dimension this, you can dimension it. Okay, this is a 2-dimensional drawing. How you are drawing. Okay, but principles, everything, what you have studied. Okay, that is prevailing. The environment is varying. Okay, from manual, I have a computers to write. Okay, so from here I can take my printout. So extensively, whatever you want, everything is available to draw your drawings. Okay, technical drawings. Suppose I want to draw an isometric view, 3-dimensional, that also I can do it. So there should be an isometric axis I should have. Okay, suppose I want to draw a box. You see, suppose I want to draw a small slab or small prism. Okay, in an isometric way I want to show it. In drafting package itself I can show it. Okay, you see here, that is snap. One command is called snap. Okay, snap. So the style I am going to change it. Yes. Okay, the snap style. It is normally it is in standard 2-dimensional plane. Okay. Now I am going to shift it to an isometric plane. Okay. So I have, you see here, standard and isometric. So already it was in S, standard. Now I am going to shift it to isometric, I. Right. Now it is, you see this vertical spacing, it is also here. Now you see this icon, the prompting, the icon you can see, it is in an isometric plane. Okay, the icon itself, it's shifting. Okay, that you have to go for snap command. So from a standard 2-dimensional plane, I can I can snap my icon to an isometric one. So from here I can draw an isometric lines. Okay, X, Y, Z axis parallel to that. Suppose line. Okay, see, I'm 20 mm drawing. Okay, 20 mm x-axis. Then y-axis, I want to draw it 20. I am giving the distance here. Keying in the distance in the command prompt. 20 I am giving in the y direction. Again, along the x direction, 20 I am giving. See, again, here I can end it. So this is a square plane I have drawn. Okay, iso plane. Suppose I want to, along z-axis, I want to raise the height of the isometric view. So F5 I have typed it is going on another axis, z-axis. So along that I want to raise a height of 10 mm. 10 mm. I have raised. Then along this we want to draw it 20 mm. Right. Then F5. So along this I want to draw it to 20 mm. So then F5. Along this I want to draw it 20 mm. It's easy. Along this I will close it. Okay. Now this, by line command I can close these edges F5. just like this. Right. So to show your isometric, you don't show the hidden line. So whichever portion you want to remove it, I can erase it. So you can go for an erase command. I can erase this. Right. So this is your isometric. It's easier here to draw the isometric views and all. Okay. Using computers. Okay. So extensively we will be studying this in your next semester. As a practicals we will be studying. Yeah.
So we use hidden lines on the page.
That will be done. That line types I can change it. In properties I can change it. That is all easy. Okay. Any line type, whatever you want to show it, I can show it. Right. So the line type, the properties I can go it. The line, whatever line, however you want to show it, that I can shift it. These are all properties. I can change it. Okay. So as using computers, using commands and icons, okay, I can nowadays we are drawing the technical drawings. Okay. So the very first we had this drafting packages, right? Directly how you are drawing the same thing, it will be drawn here using drafting packages in two-dimensional isometric views I can draw. Nowadays still if you see, so apart from drafting packages, okay, we have design packages. Okay, design packages, what it does, you have any clarification in this? So this is what you are going to use it hereafter, right? But you should remember all the concepts, standards, okay, everything what you have studied in this semester, right? That you should remember throughout your life, right? So even though you are in a computer environment, right? So here, apart from drafting packages, nowadays we are using the design packages. So in design packages, what we are doing, you can see, in design packages what we are using. So this I can take a printout, okay. The printout I can take it, I can send it for production, right? The design packages nowadays, if you see, I will create a three-dimensional, whatever design you have in your mind, that three-dimensional model itself I can create it. 3D model, straight away I can create it in design package. So what I will be doing, first of all I will be doing in the model. So these models, to create this model I have so many softwares, okay. Commercial softwares are available in various names, okay. So we have almost all the packages in our Kerala we have, right. So wherever it differs from company to company, it depends upon the interest, okay. So you will be trying to learn all the softwares in your future semesters, right. So you will be creating the model first of all. That model, it's a main thing. So whatever design you have in your mind, that three-dimensional model itself I can create it. So in design softwares. So these design softwares we have so many Pro Engineer, Ideas, Unigraphics, okay. Lot of commercial softwares are available. So the three-dimensional model you have here, we are going to, I'm just giving a preview of a Pro Engineer, okay, it's a design package. So model we will be creating, this three-dimensional model will be pushed down to various modules. Okay, you have in a design package, you have different modules. This is a modeling module. Okay, we will be creating models. So I have a drafting module also. So drafting module only what we need. To create the technical drawing, we need a drawing. Okay. So just if I am able to create a model, just I will push on to the drafting module. So in drafting module, directly I can create the technical drawing. Without drawing, similar to your drafting packages, what we have seen previously, model only will be creating. I will be pushing to drafting package, drafting module. There directly the views of the model will be created. Directly dimension. You need not use commands to draw the views. Okay, directly the views itself will be created from the model. Okay. Similarly, I have the same model will be pushed to another module called CAM, Computer Aided Manufacturing module I have. What is that we will see. Great. So similarly, the same model, whatever I am creating the model, it can be pushed to FEA package, FEA module, finite element analysis. The analysis of that design, whatever you have in your model, that can be done. That same model will be pushed to that. Okay, there I can analyze my design itself. Okay, you need not separately create the model there. Okay, the same model will be used. in FE. Similarly, in sampling also, I can use the model. Sample, okay, 3D samples I can create it. So I can say it is prototypes. Prototypes. The prototypes. So prototype also I can create. Prototype, okay, we will see this. First of all, the model how to create in a design package. Okay, it's again you will be studying in your further semesters. We will see here. This is a Pro Engineer environment world file. I am creating a new file. Creating a new file. So this, it's you see so many modules I have. Okay, the part I am going to create. That is a 3D part I am going to create. So the name of the part it is working. Okay. As it is I am giving. So this is a 3-dimensional part model environment you are going to have. See, this is a 3-dimensional part module, okay, environment in a design package. You see here, I have 3 planes perpendicular to each other. Okay, it's a 3-dimensional environment. I can create a 3D model itself. You see here, just I'm creating an extrude. Using an extrude tool, I can draw a section. Say suppose I want a hexagon or square prism, I can draw a square. So I want a shaft, I can draw a circle. That I can extrude it to a height, to whatever length you want that model. Okay, so this is a extrude. Similarly, for creating your model, whatever you are seeing, you have so many tools. Okay, you have so many options to create a 3D model. You see the extrude I am using. First of all, for this extrude I need a sketch. That is a base I have to draw it. So in your prism I need a base. That base I can extrude it to a height. I can get a prism. Okay. So similarly that base is nothing but a sketch. Okay. That sketch all through it is common for my solid. So similarly I can create a sketching. It is asking for a sketching plane in front. I am creating a sketch plane. I'm going to create a circle. Suppose I want to create a shaft. So I'm creating a circle, drawing a circle here. For a circle you want to have pentagon, hexagon, everything is available in this tool. Okay. So I'm drawing a circle. So to what dimension I want the circle? So I can dimension it. Suppose the diameter is 100. So 100 diameter, I have drawn a circle on a plane. This circle is extruded to a height to get a 3-dimensional solid. So this circle I have drawn, just I can finish off this circle. So it is asking for a height. So this height I can, what height I want to extrude it, this height I can specify it. You can say suppose 250 mm I want to have solid. So 250 mm I have. So fit I can see. I have a 3-dimensional model of the shaft. Right. So in whatever features you want to add it, all features I can add it. Okay. That you will be seeing. So any feature, whatever. Suppose I want to remove some portions here. I want to make a hole. So everything it can be done in this. Okay. In this modeling environment. So whatever you are visualizing, whatever your imagination, I can create that 3-dimensional model in this. Similar to this. Right. We have so many features. So using that I can create it. Suppose I want to create a hole here, I can create it. Suppose I want to create a hole, you see, again the same extrude is different. I'm creating from this surface, I'm going to create a hole. Right. The circle, again I am drawing. Right. So hole I am creating. So whatever dimension you want to create this hole. Say it's 50 mm hole. Right. So you see, finishing this, I'm going to remove this. Right. To what depth I want to remove it? Suppose 100 mm I want to remove the hole. You see here, it is removing the solid. It is removing the solid. So similarly, you have so many, all the features, whatever your imagination, I can create a model. Right, whatever your imagination, I can create a model using my features. Okay, so many features I have, using that I can create the model. Now this model, so once this is your design, this is a shaft somewhere you are going to have. So this shaft, I have to finalize it before my production. Okay, this shaft, how I can finalize this shaft? Okay, whether it is so what it is what I can say, it is whether it is clear all my design requirements. Okay, then only I can send this to my production. Okay, I can create this model drawing, create a drawing, that drawing I can push it to my production. Okay, that using that drawing people will be producing the same shaft. So for this, so first of all I have to, if you want to create a in a design practice, if you want to I have to analyze the shaft. Okay, for analyzing the shaft, first of all, what is the material you are going to use, right? So where it is going to, exactly this is going to fit into. Okay, so what are all the forces coming into affecting the shaft? Okay, so everything I can give it in my FEA module. So I can push this model to my FEA module. There I can all these inputs I can give it, I can see the result. Okay, so the analysis part I can see it. Okay, so that is whether it is withstanding, this material is withstanding, so whether this is withstanding the actual real condition, real loads, whether it is taking. If it is not taking, it is XA, I can shift the material. So everything will be done in the FEA module itself. Okay, for that I need a model. This model will be pushed there and it is analyzed. Okay, thoroughly it is analyzed. Once it is over, I can keep my model. Okay, this is going to be my model. So still this prototyping portion. Okay, the model, before the model, so what people design before going to a production, we will be creating a sample of that. So whatever you are designing, that sample we will be creating. That sample, how previously it is manually it is done. So for this, whatever you have designed, for that dimension, manually a sample will be created. It will take time, months time, okay, to create the sample. Even with the shaft, it is simple. We can create it in a day, right? Within hours. But your bigger design models, okay, you want to create the sample, it will take time. So for that I need a material and I have go for so many processes, okay, so many machining operations. Then I can realize a sample itself. Once that sample I can take it for my fitment check, anything, wherever this part is going to assemble, there I can fit it, okay, and I can check the fitment checks, whether it is exactly fitting to my design, is exactly matching to that assembly. Everything will be checked if I have a first sample. So that sample I have to create it. So it will take time. So nowadays we don't need to create a samples manually, right? We have a prototyping machines, okay, sampling machines we have, okay. That prototyping machine, directly this model will be pushed to that prototyping machine. Within hours I can get a model itself. It's something like a 3D Xerox, okay, but we cannot use it for production, okay. It is for sample only. It's a costly machine. Just you can push the model, I can get a 3D sample. That sample within hours I can get it, depending upon the complexity of my model, okay. That sample I can use it, use it for fitment check, everything, okay. Once it is our requirement is satisfied, so I can finalize my model. So that model, once you have finalized this model, okay, what I can do it, I have to create the drawing for this model. So where I have to push it? Drafting module I have to push it. So I can push this model to my drafting package. Okay, drafting module, you see this is the model I have. Okay, I can push this model to my drafting package. This is a model. You see I'm creating a new file. It is a drawing file I am going to create. Creating a drawing file. Okay. So which size of drawing you are going to take the printout? That drawing size it is asking, because it is A2, A3 size, A2 drawing sheet. Okay. See here, directly the views will be created here. Okay, the model only I have pushed directly front view, top view, side view. Okay, these views, whatever view you want in your technical drawing, that drawing I can create it separately. So however you want, that I can create it. So a sectional views you want, I can create, I can represent the section plane, I can have a sectional view also. Right. So only directly the views will be created as per your standard projection. Okay. Either first angle, third angle. That also I can set it. Okay. Everything will be done. I can set it directly. I can get the view. Just I have to add the dimensions. How you want to place it. How whatever dimensions you want to show it. Again, I can show the dimensions. Okay. Insert. I can insert dimensions here. Okay. Dimensions. Here to here. Suppose I want to insert a dimension. The dimension I can insert it. Okay. The dimension with the tolerance it is showing. So if you want only the nominal value without tolerance, I can give it. Okay, I can modify. This is the easiness of it. Once I have a model, I can create. Nowadays, design packages we have. I can create a model. That model will be sent to all my modules. Okay. Whatever modules, okay, I required in my design process, okay, that I have modules, okay, that will be done in a computer itself nowadays, okay, everything. So that's what you have CAD, CAM, FE. Okay, CAD is a design, right, CAM is a manufacturing, what is that you will say. So the same model I can send it to CAM also. FE, I can analyze it, okay. So I can create a model, right, I can analyze, once I can finalize my design, then I can create a drawing. Once you have created the drawing, okay, directly, right, it's not like your drafting package, you need not draw it separate. So once I have created the drawing views directly I can obtain it. That I can take the printout, I can send it for production. Okay, it is not like that before. 10 to 20 years before it is not like that. Everything it is done manually. Listen, why I am saying everything it is done manually. Suppose you can see nowadays, a month's time I am getting a new cars. Right. So how it is possible? Because of this easiness, right? So before it will take a new design of a car, it will take 2 years, 3 years time, right? So because all these things it will take time. Nowadays, within a month, I can finish all my design process. I can go for my production. I can go for my new designs. Quickly, I can produce the whatever new design I have. Right. So that is the easiness we have. So that's main prototyping also. Okay. Sampling time also just get reduced. That's why I am getting new designs very faster nowadays. Right. Because of this computer graphics environment. Right. So one more thing, this CAM, what I told this CAM is nothing. What is CAM? Computer-aided manufacturing, right? CAD is computer-aided design, right? So computer-aided manufacturing, I have another module. In manufacturing, you know. So nowadays, you know the CNC, that is lathes and all. That is standard conventional machines, okay, machine tools. Nowadays, we have CNC machines, okay. CNC machining centers we have. That is computer numerical control machines. There I will be writing a program. That program, according to that program, the model will be created exactly to that the given component is machined to that exact accuracy, right? Than a machine tool as lathe or some conventional machines. Okay, CNC machine I can produce accurate components. Okay, so for that I need a manual part program. Okay, previously we will be writing a program, part programming for that. That is a manufacturing program. So that program will be fed into that machine, corresponding CNC machine. That CNC machine, according to that program, it will be creating the, giving you the component, right? Machined component, accurate. But for writing the program, you need to know that operating system. Okay, according to that you have to write the program. Nowadays it is not like that. Okay, you need not know the part model, part programming. Create the model, I can push on to that to CAM module. So in CAM module you have different machines, different operating systems, okay, control systems. So these control systems, whatever machine you are going to use, everything I can key in my CAM module itself. Model will be the same. So that is you are going to see. Everything I can key in my CAM module. So whatever tool you want to use, okay, whatever accuracy you want, depending upon that you will be selecting the tools, cutting tools. So everything I can specify in CAM module, and I can generate the CNC part program in my CAM module. Just all these inputs, if I able to give it, it will generate the part programming itself. So I need not write the program, I need not check it. So the part programming, it is generated in CAM. So CAM is nothing but part programming generation. Okay, it will generate a part programming according to your requirement, according to your machine. Okay, which machine you want. So that program I can push it to my CNC, corresponding CNC machine. It will manufacture that. It will give you the component. Okay, that is nothing but CAM. So part programming also we need not do it. Okay, it can be generated using CAM module. So this is about the present environment. Okay, so whatever you are designing, I can design it, I can create the drawing without manually using my drafters. Okay, so the very first thing we had the drafting packages. There we will be using commands and we have to draw it similar to your manual drawing. Nowadays it is not like that. I can create a model, the same model I can keep it, I can use it in all other modules. So whatever correction I will be doing in my module, so it is a link, it is associative. So suppose I want to do some design corrections in my model. Okay, I can do that, I can change the dimension in my part model. So once I have changed the dimensions, all the changes will be incorporated in all my modules, wherever my model is there, I have. Okay, so once I can change it, I can use it for my module. Okay, finally once it is finalized, I can go for a drawing file. So that drawing only will be sent for production. You have any clarification? Okay, this is what you are going to see. So with this way I wind up my lecture of engineering graphics. Right, you have any clarification? The same, all the videos, okay, it will be available in our website in this weekend. Okay, similarly it will be available in YouTube. Okay, you can go through that. If you want that, you can bring a CD. Okay, 2 DVDs. Okay, 4.7 GB capacity. 2 CDs you can bring it. You can give it to Tamil children. He will copy it. Okay, just the CD you have to bring it. He will copy it and give it. Right, you can have that with you. So I like to. I want to wind up this. I like to thank the management and the our registrar, beloved registrar, and my beloved HOD, who had faith in my lecture and taking the videograph of my lecture. Right. At the same time, I thank Mr. Tamil Chelvan, my friend, okay, who is the person taking videos and who is using his full effort without knowing editing anything. We have done our best and we have edited and we have uploaded in that. So personally I thank him. And I'd like to give a moment and again I like to thank the team, data center team, who will be very helpful in uploading these videos. At the same time, Ms. Khatija Parvin, who is helping in uploading the videos in our website. Right. So not least my students, okay, first semester mechanical C-section students, okay, for your cooperation and patient listening in my lecture. Okay. So once again I thank all who directly contribute and indirectly contribute for this video lecture. Right. Thank you.